Welcome to mechanical tutorial. I am going to teach you different techniques in SolidWorks for mechanical engineers. I am going to train you different modules like surface modeling, sheet metal and enclosure design, product design, plastic components design, reverse engineering and many more tips and tricks in SolidWorks.
Hi, today I'm going to explain about sheet metal component. So I'm going to show you this component in folded state as well as in flat pattern. So this is the component. So let's start now. So I've taken a new SolidWorks part file. Select the top plane, go to sketch and select center rectangle, select the origin. This is 100 mm, 78. So select the sheet metal tab, select the base flange. Here I've taken 1 mm and K factor as 0.45. It should be always less than 0.5. Say OK. Now select the edge flange. Select this edge and the other edge. We are going to create two similar flanges. So here flange position we have to select material inside and say OK. Here we have to edit the sketch. We have to select the top line and this bottom edge, not this edge. We have to always select the outer edge. So this is 25. Similarly, we have to edit the sketch. So either we can give the dimension or instead of that we can keep it as driven, and we have to show this dimension. So here it's not visible, so we have to go to view, show, hide all options, and we have to select this. So after selecting this, we can see this sketch in gray color. I'll keep it in wireframe. See here, you can see this line in gray color. Now we can edit this sketch. See here, we have to select these two lines and make it collinear and say OK. So it is constrained now. So the advantage is that whenever we modify this sketch, automatically the other flange sketch also modifies equally. So that is the advantage. So this technique is used for symmetric flanges. Now select the edge flange and select this edge and say OK. Now keep it in wireframe. Give it center line. Select this line, make it vertical. Now this value is 50 and we have to select outer edge and this line. So this is 10.5. So it is not symmetric, you can see here. So we have to make it coincide to the origin. So it is symmetric now. So flange position, see here, the flange position we have to select material inside. Say OK. Now I am going to create this hem feature. Select hem and select this closed hem, and we have to select material inside. And the distance is 3.75, and here we have to select this edge. See here and say OK. See, for hem we can keep 0.5 as K factor, there is no issue, but for edge flanges we have to keep always less than 0.5. That is very much important. Now I am going to create this flange. So select the edge flange, select these two edges, keep it in right side. See here. So when we see from the front view, it has to be material inside. So it is meeting the edge. See here. So this is 13.1. And flange is material inside. And say OK. So we have to dimension this. Select the inner edge and this line. So this is very much important. So here also we need to constrain. Either we have to edit this dimension, or so we have to unhide this sketch and edit this sketch, and we have to make it collinear. See here. Hide it. So next I am going to create this flange. So select the edge flange, select this edge and this edge. And say OK. Select this outer edge and this line, say OK. Here also we have to unhide, keep it in, wireframe and select. So we have to edit this sketch and make it in collinear. See here. So here also the advantage is when we modify this sketch, automatically it updates this, so both will be symmetric. We can hide this sketch now. Now I am going to create this flange. So select the edge flange. So here keep it in front view. See, it has to be material inside the flange position. So the outer edge should match to this face. So here we have to edit this sketch. So we have to move to this end. See here, these are the dimensions I need to modify. So draw one line from here. One line from here. So it's easy to trim actually. See here, select the power trim, just trim all the outer lines. Finish. Now it's easy to dimension. So this is 10 mm, angle is 120, this is 15, .4, and this total distance is 25, and this distance is 7 mm. See, it is constrained now. So this one we have to make it vertical. So these are at equal distance, or else we can draw a center line from here to here as a reference. So say OK. So this flange has been created now. So here we can use mirror option. So select the mirror option. So mirror about the plane, that is front plane, and select this. See here. Next I am going to create this side flanges and hem. So select this sheet metal tab and select this flange, select this edge and this edge. So this is 10 mm. See, okay. Now show this sketch and keep it in wireframe. So we have to see here. This is the sketch. Now we have to go to edit sketch and we have to select this top two lines and make it collinear. See, whenever we modify this sketch, it is going to update in the other edge flange. So we can hide the sketch now. So next I am going to create hem. Select the hem feature. So this is closed hem and this is three mm. So it should be material inside and closed hem and 3 mm. Select this edge and the other side also. Say okay. See here. See this flange, we can modify this to material outside. So let's see, still it is steering off, so we have to select bend outside. So this is also important. See here. So while selecting the flange positions, we have to take care of these issues, otherwise it's very difficult to manufacture this component. So I am going to create this cutout. It is an octagonal cutout. So select unfold option, select this face, collect all bends. Select extruded cut. So select this polygon. Here we have to make it 8-sided, that is octagonal, and select the origin and place it. Now select this line and this edge, select collinear and say OK. So this is linked to thickness and say OK. Now select fold option, collect all bends and say OK. Now I am going to create these inside flanges. Select these two edges, this is 13.2 and say OK. Here we need to edit. Say OK. The other side also. Now I am going to create other flange. So select these two faces, two edges. So the flange should be always material inside, and this is a 26. Say OK. So we have to edit these two sketches. So we cannot keep unconstrained, otherwise it creates an error when component become complex. So select the outer edge and this line, it is 26. So this is also 26. Now I am going to create these slots. So select this face, go to sheet metal, select extruded cutout. Select a slot, straight slot. So here we can draw a center line joining these 2 points at this midpoint and this point. So make it horizontal. So this value is 8 mm. So width is 5 mm. So here we can use pattern, select linear pattern, so select these entities. So here instances we have to take 4. So spacing is around 10 mm. And say OK. Similarly select once again the same sketch, but we have to flip the direction. So here also spacing is 10 mm and instances 4. Say OK. Fine. See here, make it in solid, we can see these sketches of this slot and come out of this sketch. See here, it should be linked to thickness and normal to cutout, and say OK. So this is the slot. Now we have to mirror these slots. So go to features and select the mirror. Select this feature. So here we have to select the plane. Select this plane and this feature, extruded cutout, and say OK. So the other side also has been created now. Now I am going to create these fillets at this corner. So select the break corners, select this chamfer, and this is 10 mm. Select these corners, this corner, this corner, this one, and the fourth one, and say OK. See here. Similarly, select once again the break corner, select the fillet, and fillet is 7 mm. Select these two edges, similarly other two edges, say OK. See here. So once again I am going to use break corner. So this is 5 mm. Select these edges, 1, 2, 3, and 4. So similarly the other side. See here. Now I am going to create whole features. Before that we have to unfold this component, collect all bends, and say OK. So keep it in top view. Select extruded cut. Sorry, we have to select the whole simple hole feature. Select this, and this hole is 5 mm. So it is not edited. So this is 5 mm. So we have to constrain this. So select this center line, join these two lines, and select this center point. So it is constrained now. Similarly, we have to create one more center line, select this midpoint and this midpoint, and draw one circle at this center. So select these two circles, make it equal. So so it is constrained now. Say OK. So similarly we have to select whole feature, select this face. So this is around 6 mm. Say OK. Draw the center line from this midpoint and join this line, and place it at the center. So this is to minimize the dimensioning the whole feature. And it's easy to constrain also. So select these two circles and make it equal. Say OK. So it is constrained now. We can come out of this sketch. So now we have to fold this component, collect all bands and say OK. Keep it in isometric. Now select this forming tool, go to flanges and select this round flange and select this face. So for positioning we have to go to position tab, and here we can place exactly at the center. So we can pull this point, say here. See, this is how it is created now. Now similarly we have to select countersink emboss and place it here. Go to position, keep it normal, draw one center line, and place it here. And say OK. See here. So this is the final component. So I am going to show you the flat pattern. So we have to go to sheet metal tab and select this flat pattern command, and see here. Keep it in top view. See, this is the flat pattern. So this is brief about this sheet metal component. Thanks for watching.